The mission involved a specially adapted military aircraft known as the WC-130J Weatherbird, which was designed specifically to withstand the extreme conditions found inside major hurricanes, and the crew's objective was to penetrate the hurricane's eye wall and release sophisticated instruments called dropsondes that would measure critical data, including wind speeds, atmospheric pressure, temperature variations, and turbulence levels throughout the storm's structure. As the aircraft approached Hurricane Melissa and began its penetration into the outer bands of the storm, the crew encountered turbulence that was significantly stronger than what they typically experience during hurricane reconnaissance missions, and the conditions continued to deteriorate as they pushed deeper into the cyclone's interior, where the most violent weather phenomena were occurring. The cockpit instruments displayed alarming readings, while the aircraft was being violently tossed by the powerful updrafts and downdrafts that characterize the inner core of major hurricanes. And despite the crew's extensive training and experience in flying through dangerous weather systems, the decision was ultimately made to abort the mission and return to base because the structural stress on the aircraft had exceeded safe operational limits. Nevertheless, the dropsondes that had been deployed before the abort were able to transmit valuable real-time data back to meteorologists at the National Hurricane Center, and this information proved crucial in refining the forecast models that predicted Melissa's intensity, track, and potential impacts, thereby enabling more accurate evacuation orders and emergency preparations that ultimately saved countless lives in the threatened regions. The remarkable tradition of flying aircraft directly into hurricanes began during World War II in July 1943, when a military pilot named Colonel Joseph Duckworth made a daring bet with fellow aviators that he could fly a single-engine AT-6 Texan trainer aircraft through a hurricane that was approaching the Texas coast. And this spontaneous demonstration proved that aircraft could indeed penetrate these massive storm systems and survive the journey, which led military commanders to recognize the potential value of gathering weather intelligence from inside these powerful tropical cyclones. This accidental discovery ultimately resulted in the establishment of the first dedicated Hurricane Hunter Squadron in 1944, and these early missions were initially conducted to protect military operations and naval vessels from unexpected storm encounters. But the program quickly evolved to include civilian forecasting applications, as meteorologists realized the tremendous value of obtaining direct measurements from within hurricane structures. The modern WC-130J Weatherbird represents the latest and most advanced evolution in hurricane reconnaissance aircraft technology and is operated exclusively by the United States Air Force Reserve's 53rd Weather Reconnaissance Squadron, which is based at Keesler Air Force Base in Mississippi and remains the only military organization in the world that routinely conducts hurricane penetration missions. These specialized aircraft are specifically modified from standard C-130J Super Hercules cargo planes with extensive reinforcements, including strengthened wings, enhanced structural frames, and specialized mounting points for weather instruments. And they are equipped with advanced Doppler weather radar systems that can map the three-dimensional structure of hurricanes in real time, sophisticated data collection equipment that can measure atmospheric conditions with extreme precision, and satellite communication systems that allow immediate transmission of critical information to forecasting centers on the ground. Hurricane reconnaissance missions have become an absolutely essential component of modern meteorological forecasting operations because satellites orbiting high above the Earth, despite their advanced imaging capabilities and wide coverage areas, cannot provide the detailed interior measurements of wind speed, temperature, humidity, and atmospheric pressure that are necessary for accurately predicting a hurricane's intensity changes, future track, and potential impacts on coastal populations. The dropsondes that Hurricane Hunter crews deployed during their missions are sophisticated cylindrical instruments that descend through the storm on small parachutes while continuously measuring and transmitting atmospheric data from various altitudes, and this information is immediately fed into complex computer models that meteorologists use to generate forecasts and warnings for threatened areas. The invaluable data collected by Hurricane Hunter crews over the past 8 decades has been directly responsible for improving hurricane forecast accuracy by approximately 30% compared to forecasts that rely solely on satellite observations and computer models without direct measurements. And this dramatic improvement in prediction capability translates into significantly better warning times, that give coastal residents additional hours or even days to prepare for approaching storms, more accurate evacuation orders that ensure people in the most dangerous zones are moved to safety while avoiding unnecessary evacuations in less threatened areas, and more effective emergency response preparations that allow first responders and disaster management teams to position resources exactly where they will be needed most. These improvements in forecasting and warning systems have collectively saved thousands of lives throughout coastal communities around the world and have prevented billions of dollars in property damage by enabling better preparation and protection measures before hurricanes make landfall.
Oh, look, look, look. Go around.
Approaching decision height. Minimums.
Go around. How's it break? Zero.